Hey, the shop's pretty quiet right now, so I'm going to take this chance to go over a couple things in the next video, or next two videos maybe, that confuse a lot of people in the field getting started. The first thing that I'm going to cover is thermostats. I've talked about them before, but we have this running joke with the coworkers and everything that I have here. The first thing that everybody seems to blame is the thermostat. Your heating and air is not working, whether it's for heat or for cool or for anything, and everybody blames the thermostat. I have seen experienced technicians go in and the first thing they do is change the thermostat. No checks, no reason, nothing. They just change the thermostat. I personally don't like it. I don't think it's right, and that's the first point I want to make. And number two is refrigerant. If it ain't a bad thermostat, then it's always low freon, right? Everybody says low freon, low freon, low freon, but nobody ever checks it right. So in this video, I'm going to try to walk you through a couple different thermostats. So this is how I would check it, and we'll learn a couple things about that as we go. So stay tuned. We're going to talk about checking the thermostat and how you know it's bad. Hey, so for this video, I'm going to use a package unit to start off with, and I've just got it plugged into an outlet over on the side. We've got a 230 volt plug. So we're going to look at what the thermostat is and how you know it's bad. All right, recently we were doing some things in the shop with some guys, and we were trying to teach them. Actually, I'd put a problem in a unit, and their task for that day for that lab is to figure out why the unit's not working. So, and like I said, we commonly get people that will blame components, but you never take your meter out to actually troubleshoot it. So I'm hoping to clarify a few things about the thermostat and show you some numbers and give you something to look at so you don't make the mistake of misdiagnosing it. Everybody, like I said, the thermostat's the thermostat. Most of everything in the residential market that I've ever seen, that's not a communicating system. There are communicating systems out there that are a 3-wire or a 4-wire system. I've even seen a 2-wire thermostat that had a sub base that was completely wired in. But this is just your standard, you know, mom and pop, grandma style thermostat. This is nothing fancy, no frills. So we'll talk about those hopefully in a later video when we get there. But for this thermostat here, I've had them in videos in the past. This is on a heat pump package unit. So we've got everything wired here for a heat pump. You can see all the colors, the color coding that we've used. We mount the thermostat right to the side. The display goes out. I don't run batteries in it. So like I said, nothing fancy. And this thermostat should come back on. There it goes. So the thermostat's the brain of the operation. For me, personally, I think about our low voltage and high voltage working together with the thermostat. The thermostat tells it what to do, right? Tells the system when to work and who to work. So the sequence of operation that I keep in my mind is thermostat's going to call for something, and all those wires that we wire on the sub base, they're going to go to a coil, a relay coil for the indoor fan, a contactor coil for the outside unit, a solenoid coil for the reversing valve, or whatever for heat strips. You know, the list goes on and on depending on what you have. So thermostat controls the coil. The coil is going to move a switch in that relay or contactor, and then that switch is going to pass high voltage power into a motor or a heat strip or something like that. So the thermostat commonly gets blamed, but how do you know the thermostat's the problem? Okay, I get some checks that people do, and they don't know how to make sense of it. Okay, so I'm going to put my meter right here on the side. All right, and we're going to walk through a couple voltage checks and give you something to think about. All right, so here's where I think people get messed up as far as voltage checks. Okay, one thing that we can do to check to see if our thermostat is good is to check voltage. Okay, now the first thing you got to remember is that you have to have voltage going to the thermostat to make anything happen. All right, so what you can do, and I'll show you this. What I like to do, if you have a thermostat sub base here that has where you can actually see the pins, don't try to jam your lead in there. I've got a 2-wire piece of thermostat wiring, and what I'll do is I will cut me a length of scrap and I will put that in like my red and C, all right, my R and C I should say, and then I have a little piece out here that I can grab, and I can check 24 volts, and you can see there I've got 27 volts. All right, if you can prove power into the thermostat, that is a starting point. That means that this thermostat, of course, has the required power to power it as a load, and also that R is going to be distributed out through the system once this thermostat calls for heating or cooling or fan or reversing valve or whatever. All right, so the power check is always, to me, kind of first and foremost if you have any doubts. Now, just because you see the screen lit up doesn't mean that you actually have power on R or R in common. If you check the total power supply, you could have batteries in the system. So if it's blank because of a float switch or whatever, or bad transformer, don't assume that, you know, anything really. Take your cover off, make sure you don't have batteries, or if you do, and then do a simple voltage check. Now for me, I tell the guys that I come across, the only thing that you can check on this subbase is for power. If you know you have power there, then that is about as good as you really need it to get, because checking voltage to any other thing is probably going to confuse you. Yeah, I just dumped the thermostat right there on the floor. So, but anyway, you're going to get confused if you don't know what voltage you should get. All right. So when you're checking voltage, and I'll go through and show you here. You just saw me check R and C. I got 24 volts. If I were to check R, if I were to leave that one wire in that pin and check to G, all right, I'm gonna go R to G. If I do the same voltage check on this thermostat, guess what I'm gonna get? 27 volts. And you're like, oh, I got power. Okay, let's check R to Y. All right. Oh, there we go. 27 volts. Okay, I could do this from R to every wire on here, and I'm probably going to get 27 volts. And the reason is you're checking across a switch. All right, voltage checks and switches mess people up. When you remove the faceplate off of a thermostat, you pull all the switches. That circuit board that's in here, if it's old school and it really was the mechanical switches or something, you are removing that from in between the wire. You are removing it from the circuit, and you're going to get 26 volts on everything, and all you really have is power on R. Okay, so don't look at it as R is passing power to G, or R is passing power to Y or W, because it's not. You are checking with your leads. You are taking the place across that switch. You are the middleman where the switch was, and anything from R to any of those other wires, common included, is going to be 27 volts. Expect that. All right. The only thing that you should be checking, in my opinion, is R to C. That's it, because it's the only thing that's going to make sense for a lot of you young guys. All right. So when you go to a thermostat, if you want to see if it has the capability to work, check power, check R and C with your leads, with your meter, and if you have 26 volts, that's enough. I would put the faceplate back on and be done with it. Okay, that was a little weird. I don't know what happened there, but as long as I've got power, I know what I can expect now. Now what I can do is I can turn the system on, for example, for the fan or the compressor, or I can turn the heat strips on. And what should happen is the R should go across whatever switch you just told to close. R goes across the switch and comes out G. That is a power output, And now we should go check at the other end of this wire. It's going to be at the air handler, it's going to be at the outdoor unit, it's going to be, in this case, right up, 2 feet away, going into the service side of the package unit. But the R on this end has the power to make something work. What you need to do is go to the other end and make sure that it gets there. Okay, so I'm going to turn the fan from auto to on, and we're going to go right across the corner here, and we're going to check from G to common. Everything that you need to check, right? For the guys that I have in the lab and stuff, there's one thing that I tell them, right? Well, there's a bunch of things that I tell them, but this is what I'm going to tell them about the thermostat. Every wire, okay? One more time, let me pull this off. Every wire in here is ultimately going to come from R, except for one, and that's common. If you have a common, that is the only wire that isn't going to originate from R. Okay? The common is there so we have a display on our unit. Back in the day, and I'll show you a thermostat in just a minute. Back in the day, you didn't have a common necessarily. We used mercury. Okay, mercury was that liquid metal, and it passed power through it once the bulb tilted and all that. So if you're checking a thermostat subbase that's a digital thermostat, and it's not the communicating or anything crazy, right? Just a straight up thermostat that's digital, common is the only wire that's not going to eventually or ultimately come from R. R turns into W when we want heat. R turns into O when we have a reversing valve that's, depending on the type, heat to cool, O and B and all that, right? R turns into G, R turns into Y, R turns into Y2, whatever. Common is the only one that doesn't. So everything else is really R. So what's the difference in R and R? It should be 0 if we could check that, but because we remove the switches, now we're checking one side of power across a switch, and that's where guys get confused. Okay, so let me turn this back on. We're going to let the thermostat come back up, and like I said, for me, check power here at the thermostat. The next thing I would do is I would go to the other end, and you can see we've got our fan on in the on position here. The system itself is off, so we would go to the other end of the wire. Alright, so most of the time in the package unit you're going to have a little corner right here where all the low voltage is. So what I'm going to do is I'm going to undo the green wire, and I'm just going to expose that thermostat wire from the thermostat. So if I'm checking it, like I said, I'm going to grab that green wire here, and I'm going to look for common. Now usually what I would do is tell you, don't worry about the common in the wire nuts if you're inside a package unit or the air handler. Try to find the common at the transformer. Sometimes you can just wiggle that little wire off of the common and you can check it there, and I've got 27 volts. So in this case, I know that my thermostat is sending power down G because I'm checking it at the first spot, right? The first connection where it connects from the field wiring into the factory wiring. Okay, so check the common on the transformer. Even if you grab the common in this package unit, I could grab the common off of the contactor coil, because common is common is common. Okay, as long as you know it's a common, you're on the correct side of power there. So if you didn't have 24 volts, that's when you would check something else. Okay, so in my case here, let me. So real simple, I just pulled the thermostat face off, right? So if I were to be checking here and I grab the common on my transformer and I get something weird, 11 volts, 10 volts, 0 volts, right? Something other than 24, I know that my thermostat has to send 24 volts down G. If I don't see that, then I don't blame the thermostat yet. What I'm going to do now is maybe check another circuit like the Y or the O, and I'm going to find out. I try to troubleshoot as much as I can to gain as much information. But if we were in a call for cooling and I checked G to common and I got 0, but I checked Y to common and I got 24, then that's just one problem with that circuit, or that one circuit I should say, the G circuit. So what I would do then is not blame the thermostat. It could be a bad thermostat, but it could also be a bad wire, all right? What you would need to do is a continuity check. I've done videos on that. I've preached about that enough. But don't just change the thermostat. Know what circuits you're involved with and check voltage. If the voltage isn't present, then check continuity on the wire. If you've got a good wire and no voltage, then assume that the thermostat is not sending power and that it should be replaced. All right? Makes sense. What you can do, I'll show you one little trick just to show you, right? All right, so let's say that you have identified a bad thermostat. Before you go to town or before you not check something else out, right? If you think it's just a bad thermostat, go ahead and try to finish checking the system, right? I had an older tech years ago told me, you know, don't just stop at the first problem that you see. Try to troubleshoot as far as you can. This thermostat is nothing to be, you know, to stop all work. If you think that it's not calling for the fan circuit to work or for the cooling circuits to work, all you have to do, right, since everything comes from R, all you have to do is pull out the circuits that you want, except for the common, right? And you can take all those circuits right there at the thermostat, and if you lined up the wires good, take a wire nut and use a wire nut in place of that thermostat switch. If you think it's a bad switch, then jump it out, and at least that can let you finish troubleshooting, let you finish checking. I sure would hate to run to town just to grab a new thermostat if I didn't have one on the van, and then find out that I also need another contactor or another capacitor or something like that, right? So troubleshoot as far as you can. In the case of the thermostat, we can rectify that problem with a wire nut. Okay. So hopefully you get that. If you were to take all those wires and jump them all together, then everything in the system should run. We can make the heat and the cool run at the same time if we wanted to, because we are truly controlling that switch. The thermostat is going to be broken down into heat and cool. It's not going to be everything. But if you ever think your thermostat is a problem, troubleshoot it properly. You can use a little cheap trick like a wire nut to make everything work, so you can finish diagnosing the system in its entirety. So I hope that helps a little bit. What I'm going to do is put these wires back and let this system alone, and I'm going to show you one other thermostat type before I go. Alright, now here is a thermostat. It is a battery powered, I should say, thermostat. So I'm going to turn it on. We haven't used this one in quite a while, but I'm sure there are some older systems out there with some older thermostats. Now this one, if you look at the terminal blocks or the terminal screws for the individual circuits, you'll notice that there's not a common. We don't need a common for this one. It has to be battery powered. So all you will see is a green wire, a red wire, a white wire, and a yellow wire. Okay, this particular setup is on a package unit that's on a roof. It's a gas pack, so we don't have any O or anything, even though we could if we programmed it for that. So old thermostat, right? So you can see here's the actual thermostat, all this circuitry and stuff built into a little printed board, got the display and everything, but there is no common. All right, if you ever see one of these, and I've already got the faceplate removed off of it, the thing with this type of thermostat is you're not removing the switches. This is just a thin cover that was over it, so it hides all the circuitry and the terminals and everything. But I've still got my fan switch, you know, on and auto, and I've still got my heat and cool switch. And we can switch it to heat and cool and operate the fan down here just like normal. So it's a digital thermostat, but it's very much old school with the little slide selection switches or whatnot. But anyway, if you ever come across one of these type of thermostats, this is one where you actually could use your meter, okay, to check with everything on. All right. Now, because it doesn't have a common, if you ever go to one that doesn't have a common, that's not a big deal. All right. You just have to know that if you have power on R, right, there's no power from G to O or to Y or anything. Everything originates from R. So if you were to go here and go from R, right, if I were to go from R to G, my meter's off screen, but it says 26 volts. If I were to go from R to W, it still says 26.1 volts. R to Y, I've got 26.3 volts. All right, my system is off. It's powered because of the batteries, but from R to anything is going to be 26 volts if you have power on R. By us not having a common here, I can still use the R and the G or R and W or R and Y to kind of get an idea if I've got power on R, since I don't have a common, because I'll get 27 volts across any of it. Now if I were to turn the fan on, I'm going to turn the fan on real quick, and if I go from R to G now, I get 0. Now you can't hear it running because it's on the roof, you know, 20, 30 feet away from me, but I just had 26 volts on this check from R to G. And it's only because of this thermostat and the way that all the screws and the switches are left in place. But I can check it on this one because of the way it's built. But why would I have 0 volts between R and G? It's because now that thermostat is allowing power to come out of G, right? It came in on R and now it's leaving on G. So 24 volts going in, 24 volts leaving. What's the difference in 24 and 24? 0. So I know that my thermostat is indeed sending power, at least to this screw terminal. Whether or not the wire's good is a whole different thing, okay? So probably won't see too many thermostats like this because, like I said, in our state of the industry right now, everything's kind of gonna move real fast, new refrigerants and new technologies, and we're probably going to get rid of a lot of non-communicating thermostats and systems because it's all going to go communicating eventually. Or at least that's the thought. So if you ever come across one like this, you can do all your voltage checks at the actual thermostat itself because you're not removing the actual brain of the system, right? So just wanted to show you that. Hopefully it doesn't confuse you. If you have any questions, let me know. I'll try to help you out just like always.